So I'm going to explain today I'm going to explain FPGAs. What are FPGAs? The full form of the FPGAs is Field Programmable Gate Array. So you might be thinking. So first of all, I'll tell you what is the requirement for watching this. Is that you have to have knowledge of programmable logic device in digital circuits. Expect you guys to have the knowledge, some knowledge, basic knowledge about the programmable logic device, because FPGA is nothing but a field programmable logic device. Okay, and let us start with the field programmable get array. So let me tell you the advantages of field programmable array. They provide several advantages over traditional get arrays or mask programmable get arrays. Those are called MPGs. So, as the name suggests, mask means you are making mass production of this type of chips. Okay, so they are the traditional get array, and they can be used to implement any circuit, but it is programmable only in the factory. So MPGs are only programmed in the factory. A specific mask to match the particular circuit is created in order to fabricate the gate array. Okay. The design time of this type of circuit, the MPGs, are few months, and whereas the design time the FPGAs takes is the hours. So the making time, the manufacturing time reduces from months to the hours. Okay, if one adopts FPGAs instead of MPGAs, yes. So the designing become very easier in FPGAs, and this is tremendous. This is tremendous advantages. Okay, uh, advantage when it comes to time to market. So when you are hurry, you know, to making advantages too. So the disadvantages are FPGAs are. There was a one more advantage of FPGAs over MPGAs. They are very cheaper. So yes, as I said, these are very cheaper. Okay, so FPGAs are less dense than traditional gate arrays. So here we are talking about, we are making user making it. So one person can make the FPGA. So it suppose can be supposed as like it is not too condensed, or sorry, too dense. It is very like less dense. So FPGA lot source are sent to merely achieve to programmability. So of course, FPGAs have a better density over FPGAs, so they have better performance over FPGAs. So FPGAs make easier. It is only for to decrease the workload. But if you look at the MPGs, they are more faster than more. They have better performance over FPGAs. That's not a good point. So yes, and the FPGAs have high resistance and capacitance, so they slow down the signals. So FPGAs are slower. So as I said, FPGAs are slower than traditional gate array. Traditional gate array means MPGAs. Also, interconnection delays are unpredictable. So interconnection. So I'll say what is interconnection, what is programmable logic blocks, what is IO block. So I'll say these are all components. These are main building blocks to build FPGAs. So PLDs like PAL. Okay, this is what we have discussed previously. PAL means what? Programmable array logic, and gate array logic. So are simple and expensive, whereas SimPLD are faster than FPGAs because they are complex. Okay, and it is field, so you can make on that particular field where you are now. It means it's analogy that field means wherever you are now, you can build from wherever. Okay, and are cheaper. Overhead of programmability is fairly low. Yes, so have you don't have to program so much in PLs and CPLD. The main advantages of CPLD over FPGAs is lower cost and predictability timing. So yes, Zinlix. There are many manufacturers, many vendors who make these FPGAs and these MPGAs like products. So it is first is it's main Zinlix, Altera, Lattice Semiconductor, Actel, QuickLogic, Atmel, whatever. So now how FPGAs are organized in one particular chip. So what is the architecture of FPGAs? So it has three main programmable part element in it. One is programmable logic block. So the blocks which you have put your uh, logic on. Like you want to build in one block. Say you have put 32-bit adder. In another block you have put multiplier, or in another blocks you have put 3 to 8 and priority encoder. So these are somehow interconnected. That's why you have put them, of course. So they have their own part and they will make the whole circuit. So that is what the FPGAs. And the logic blocks, the one logic block 2, logic block 3, they have the input and output blocks. Sorry, they have their they have to be connected somehow. So they, that is called interconnection. So programmable routing resources. So the one's output may be another's input. So that's how it works, right? And the input and output blocks. So the chip may have some input given to it and some output from it. Okay. Okay. Of course, that's why we have built that we want to give some output and we want to get some. Sorry, we have to give some input and we want to get some output from it. So remember the three main part: programmable logic blocks, programmable input output blocks, programmable routing resources. What makes an FPGA distinct from CPLD is the flexibility, general purpose interconnection. So you have flexibility. You can build anything and however you want. Okay, that's how that's the main advantages of CPLD, because it's very flexible from CPLD. And in CPLD, in it, interconnection is fairly restricted in the sense that you cannot go like from this to this. You have to go. You know, they have put some constraint to which you followed, to which you have to follow while building a chip in CPLD. In FPGAs, you can interconnect any two blocks via anything, any connection will be suffice. The general purpose interconnection in CPLD, FPGA, gives a lot of flexibility, but it also has the disadvantage of being slow. Yes, this is what you discussed, right? Connection from one part of the chip to another part might have to travel through several interconnect points, resulting in large unpredictable signal delays. Uh, the, the architecture of CPLD, there are types of architecture. You can build FPGAs on. So the main four are there. We consider mainly four, and there are many which has vanished. We don't use them right now. Nowadays. So the one is matrix-based architecture. So it is also called 2D array. So you have column of blocks and a row of the blocks. Sorry, a row of the block and column of the block, in which you have put some your logic in the blocks and then they are interconnected somehow. And it's kind of a net, 2D net. You can see the row-based architecture. So in row-based architecture, you only see the rows of the blocks. So it is kind of 2D array, 2D architecture. So yeah, so a logic blocks in, so it's a matrix based architecture, symmetric array. So the logic blocks in this type of FPGAs are organized in matrix like fashion. So you can imagine, right? You all know matrix. What is matrix? Row based architecture is only contains rows. Okay? The architecture were inspired by traditional gate array and our logic gates in this architecture are organized in rows. So it's okay. Thus, there are rows of logic blocks and thus there are rows of logical blocks and routing resources. The routing resources is fuck the fuck. The root the routing in this architecture is often called one-dimensional channel. Okay, so this is what we've discussed. So this is the architecture of today, and this is the row. So in hierarchical, you can imagine hierarchical means there is a only root interconnect, and then they have the child interconnects interconnected to it. So this is how it works. So you want to interconnect two what you say blocks, then signal has to go to the upper level of the interconnect, then the global level of the interconnect, and then the local, and then that block. So it's the topology, man. This all are topologies. So you can anyone you like. Technology. So what technologies are used in FPGAs programming? So let us see that one by one. So in general, FPGAs use one of the following programming methods. So static RAM. So static RAM. So programming technology. So programming technology means you have to you are given some inputs and you have to get some output based on the input. So based on the logic you want to create, like so you want to create a full bit adder. So you will be given three input and you have to get the two outputs. So this is how it's all works. So you can build like lookup table like fashion, like build your own logic. Lookup table means these are stored, okay, one mapping to another. The input is mapping to the output mapping, okay. So you can build your LUTs like structure and all. So this is whatever configuration bit. So SRAM is based on the LUTs. So these bits are stored in the SRAM. For deciding the LUT functionality or interconnect are called configuration bit. Yes. So SRAM, static RAM cells usually take the one cell of the SRAM takes 6 transistors. So you can imagine the only once even the one cell takes 6 transistors. Okay. So there are hundreds of thousands of cells would be there. So they would take around millions of transistors. Okay, so here we are talking millions of transistors. In FPGAs is not viable. In FPGAs, if you are building Apple laptop, then it's totally viable. But now you are building a simple FPGAs. So the SRAM is very 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 dense and very hard to to stop. So one advantage of using SRAM is that it is volatile. So volatile means it can be you know you must have heard of volatile energies. Memory, it can be removed, completely removed, like erasable, completely erasable. So that is well volatile and you can write new. So if you want to erase the old stuff from it, so erase the you can erase the old stuff and implement the new stuff in it. So you can write a new content again and again. This provides flexibility during prototyping and development. Another advantage is that the fabrication step for making SRAM cells are not different from the steps of making logic. The major disadvantages of SRAM programming technique is that the 5 or 6 transistors are use for every SRAM cell. So this adds a tremendous cost to this chip. So this is what I have discussed. Okay. So if the FPGA is kind of not very much big scale thing. So if you really want to some big make some large scale thing, like you want to have your very motherboard, let's say computer's motherboard, then there would be thousands of FPGAs would be required, so that you have to do so much things in it. So the one FPGAs can't handle it, so you have to create so many FPGAs, and one FPGAs require millions of transistors. So think about the thousands of, so it would be like trillions of transistors. So it is not viable because even Apple uses millions transistor, and we are using only a motherboard, and we are requiring trillions of transistors. So this is not viable, absolutely not viable. So are spent in achieving this programmability. Being volatile can become a disadvantage when FPGAs is used in a final product. Okay, hence the SRAM FPGAs are used. A non-volatile device such as EPROM would be used to permanently store the configuration bits. So we don't want to be like losing our information, because volatile is something that can be removed anytime. So we don't want to be having that. So there are EPROM and EPROM, erasable programmable ROM, and electrically erasable programmable ROM. So this is how it's done, and EPROM are slower than SRAM. So yes, EPROM are slower than SRAM because they are fixed. You have first you implement things, then you cannot write a new content in that thing. So you have to completely erase the thing. So slower than they are slower than the fact that is just they are slower than SRAM. So hence SRAM based FPGAs can be programmed faster. EPROMs also require more processing step than SRAM. SRAM based switches have high on register and high static power consumption, and whatever the EEROM is similar to EPROM. The difference is that it can be removed electrically, and it is in whatever it is put from like laser cell or something like that. But removal of the gate charge can be done electrically. And there is another variant we can use to build FPGAs, that is flash memory, is a form of EPROM that allows multiple locations to be erased in one operation. So that is kind of good plus point here. The flash memory stores information of floating gates transistor as in the traditional whatever antifuse. Discuss the SRAM's disadvantages. So SRAM FPGAs have several disadvantages. They contain high area overhead, so they contain comparably more area than the other or the double EROM. So and it is volatile and it has a large delay, because we have seen that they contain five or six transistor per one SRAM cell. So we can say that the delay would be larger. So volatility and so on. And volatility can be advantages and can not be advantages. So we are not so sure about the volatility. However, in circuit programmability, the fast programmability have made them very popular.